Our next section in 1.3 is still evaluating limits, but now here is kind of a special situation that we get. So, evaluating limits. We said that our first step in evaluating a limit is to substitute the value that we're approaching. But if you substitute and you get a non-zero number divided by zero, so remember, this is not 0 over 0, okay? Then the limit is going to equal either infinity or negative infinity. So let's take a look at what that means. Let's say we have this function, f of x equals 4 over x plus 5. So what is the limit as x approaches negative 5 from the left? All right, so now imagine plugging in a number to the left of negative 5. What's a number to the left of negative 5? How about like negative 5.1? Okay, now if I put in a number to the left of negative 5, like negative 5.1, so if I add that to 5, I get, well, negative 0.1. Now, the key is that I get a negative number, right? Now, let's say, remember, it's the limit as x approaches negative 5, so we want to get closer to negative 5. So what about like negative 5.01 plus 5? I'm going to get negative 0.01. All right, what if I get closer to negative 5, like negative 5.001 plus 5? That's going to equal negative 0.001. Now, with a limit, we want to get closer and closer and closer each time. So when I do that, I get negative 5.001, negative 5.0001, and so on. What the fact is that I am still approaching, well, think about it, negative 0.1, negative 0.01, negative 0.0001, negative 0.00000000000000000001. Of course, I'm approaching 0. Now, the key is that I'm approaching 0, but from negative numbers. So the way that we're going to write this is we're approaching 0 from the left or from the negatives. And so if I have 4, which was my numerator, divided by 0 from the negatives. Now, I want you to think about it. 4 over a really small negative number. Well, we're going to be approaching negative infinity. Think about like if I were to take 4 divided by negative 0.0000000001. I don't know. How about that? That's going to be a really huge negative number, right? I mean, I don't know how many zeros I have there, but that's going to be a really large negative number. It's going to be like negative 40000000000, right? It's going to be a really huge. So we say that we are approaching negative infinity. All right. What about if I approach negative 5 from the right? So now, instead of like negative 5.1, what is on the right of negative 5? So that would be like, how about negative 4.9, right? If I add that to 5, I'm getting a positive 0.1, right? Then let's say, well, instead of negative 4.9, let's get closer. Negative 4.99 plus 5. Now I get positive 0.01. What about negative 4.999, of course, plus 5? Now I'm going to get even closer, 0.001, right? What about negative 4.99999999999, and so on, right? I'm going to get, well, I'm going to get really close to 0 once again, right? But from the positive number. So now if I'm taking 4 divided by 0 from the positives, now that's like 4 divided by a really small number, but positive number. So I'm going to be approaching positive infinity. So now, of course, the overall limit, well, these two are not the same, right? So, of course, the only thing we could say is does not exist. But what is actually going on here? All right, so this is the existence of a vertical asymptote. So at negative 5, let's say negative 5 is right here. As x approaches negative 5 from the left, we're going towards negative infinity. So there must be a vertical asymptote here, and I'm going down towards negative infinity from the right, from the left, and up towards positive infinity from the right. So this is how it would show up in terms of a limit question. So the key is to understand whether we're approaching zero from the left or zero from the right, so that we know whether we're approaching negative infinity or positive infinity. All right, so let's examine. All right, so the first one, all right, f of x equals 3x over x minus 2 squared. All right, so now limit as x approaches 2 from the left. All right, so now if I plug in a number to the left of 2, like 1.9, 1.99, 1.999, right? 3 times those numbers are approaching 6, right? 3 times 2 is 6, so 3 times 1.999999 is still approaching 6. All right, now, in the denominator, 2 from the left, so like 1.9 minus 2, that's a negative number. So I'm approaching 0 from the negatives, but I'm squaring it, right? X minus 2 squared. So if I take 6 divided by 0 from the negatives squared, remember, if I square a negative, I get a positive, right? So 6 over 0 from the positives means I am approaching positive infinity. All right, what about 2 from the right? So once again, the numerator is still approaching 6, right? It doesn't matter from the left or from the right, because from the left of 6, like 5.9, or from the right of 6, 6.1, those are positive numbers regardless. So we're approaching a positive non-zero number, which is 6. All right, what about the denominator? All right, so now 2 from the right. Well, 2 from the right would be like 2.1. So 2.1 minus 2 is a positive number, so we're approaching 0 from the positives. But then once again, I'm squaring it. So if I square a positive number, I get a positive number, which means 6 over 0 from the positives is positive infinity. So now a lot of people say, okay, well then, if the limit from the left is positive infinity and the limit from the right is positive infinity, then doesn't that mean that the overall limit is positive infinity? Well, you could write it, but remember, infinity is not a number, and so we would have to say that limit does not exist. So what does this look like graphically? Well, graphically, here's 2. We have a vertical asymptote there. How do we know it's a vertical asymptote? Well, because we got a non-zero number over 0. All right, and then that means that from the left, we're going upwards, and from the right, we're going upwards. All right, let's go over to this next example. All right, so f of x equals 2x squared over x squared minus 1. So the limit as x approaches negative 1 from the left of f of x, limit as x approaches negative 1 from the right of f of x. All right, so what is the number to the left of negative 1? How about like negative 1.1? All right, so if I plug in negative 1 to the numerator, 2 times negative 1 squared, that's still going to be approaching 2 no matter how you cut it. All right, now, okay, I am taking negative 1 from the left, squaring it, and subtracting 1. So this is where some people get a little confused. Negative 1 from the left squared, well, we could do it 2 different ways. One way is x squared minus 1. Well, that actually factors into x minus 1 times x plus 1. So sometimes people like looking at that because that's a little easier. Okay, so negative 1 minus 1, well, that's going to be approaching negative 2, isn't it? That's a negative number no matter how you cut it. But then negative 1 from the left plus 1, that's approaching 0. But from the negative or positive, well, remember, if we're doing negative 1 from the left, that would be like negative 1.1. So negative 1.1 plus 1, that is a negative number. So now I have 2 divided by negative 2 times 0 from the left, but that's a negative number. So a negative times a negative is a positive. So we're approaching 0 from the positives, which means we're approaching positive infinity. Next, the limit as x approaches negative 1 from the right. Well, once again, we're still approaching a numerator of 2. And if I have negative 1 minus 1, that's still approaching negative 2 times negative 1 from the right. What's the number to the right of negative 1? Like negative 0.9. Negative 0.9 plus 1, that is now a positive number. So 2 divided by negative 2 times 0 from the positive, that's a negative times a positive, which means we're approaching 0, but from the negatives, which means 2 positive number divided by a negative number, 0, we're approaching negative infinity. And so the limit from the left and the limit from the right are not the same, and so does not exist is the only thing we can write. So graphically speaking, what must that mean? Well, negative 1, there is an asymptote once again. So here from the left, we're approaching positive infinity, so we must be going up here. And then from the right, we're approaching negative infinity, so we must be going down there. All right, on to slide number 21. Now it just says investigate left and right hand limits, then evaluate. So on the previous examples, I told you limit from the left, limit from the right, right? But now we're just going to have to do that on our own. So limit from the left, limit from the right. All right, so imagine the limit as x approaches 1 from the left. All right, so x cubed minus 8 over x minus 1. All right, 1 cubed is 1 minus 8. So I'm approaching negative 7, right? The numerator is approaching negative 7. Doesn't matter if it's from the left or from the right because those are all negative numbers. All right, denominator, 1 from the left. So 1 minus 1 is, of course, 0. But what is a number to the left of 1? Like 0.9. 0.9 minus 1 is a negative number. So now I'm going to have a negative 7 over 0 from the left. That's a negative over a negative. That means I'm approaching positive infinity. All right, what about the limit as x approaches 1 from the right? All right, so once again, x cubed minus 8 over 1 minus 1. All right, so numerator still approaching negative 7, no matter how you cut it. All right, and then, x minus 1. So from the right, what is the number to the right of 1? Like 1.1. 1.1 minus 1. Well, yes, that's approaching 0, but from the positive. So now I have a negative over a positive, which means that I'm approaching negative infinity. These two are not the same. And so the only thing that you could write for this is that that limit does not exist. All right, but what would that mean graphically? Well, at 1, we have an asymptote, but from the left, we're approaching positive infinity. From the right, we're approaching negative infinity. All right, this one, same idea. All right, we want to evaluate limit from the left, limit from the right. So if I were to evaluate the numerator, the limit as y approaches 2 of y squared plus y minus 2. So I get 2 squared plus 2. So 4 plus 2, 6 minus 2 is 4. So the numerator is going to approach 4 no matter what. It's from the left or from the right. All right, but what about the denominator? Y minus 2. All right, 2 minus 2 is, of course, 0, but 2 from the left. What's the number to the left of 2? Like 1.9. 1.9 minus 2 is, of course, a negative number, so I have a positive over a negative, so I'm approaching negative infinity. All right, what about the limit as y approaches 2 from the right? So y squared plus y minus 2 over y minus 2. Of course, the numerator is approaching 4. Doesn't matter from the right or from the left because it's positive. All right, but now 2 from the right. 2 minus 2 is, of course, 0, but 2 from the right. What's the number to the right of 2? Like 2.1. 2.1 minus 2 is a positive number. So positive over a positive is positive. Now, these two are not the same, so the overall limit, the only thing we could write is does not exist. But what does this mean graphically? Well, here is 2, right? And so then we have a vertical asymptote there. And that means that from the left, we're approaching negative infinity, and from the right, we're approaching positive infinity. All right, so on to slide number 22. All right, so now we want to make sure that we can kind of go the other way. Once we're told certain information, can we draw a picture that would resemble them? All right, so first of all, we are told f of 0 equals f of 1, which equals f of 2, f of 3, f of 4, which equals 3. So what does that mean? There are points at 0, 3, 1, 3, 2, 3, 3, 3, and 4, 3. That's what that statement tells us. Okay? It doesn't tell us it's a horizontal line. It simply tells us there are points at each of those spots. All right, now, you are told that the limit as x approaches 2 from the left of f of x is -1. So what does that mean? Well, here is 2. So the limit as x approaches 2 from the left is -1. Oh, I guess my drawing isn't great. There should be a -1 down here. All right. And so we have an open circle here, right? It can't be a closed circle because there's already a closed circle up here. But as we come towards 2 from the left, we're approaching a y value of -1. All right, so that's all we can draw at that point. Next, the limit as x approaches 2 from the right is 3. So now, here is 3. From the right of 3, I must be coming towards that closed circle. And I know it's closed circle because I was already told that f of 2 equals 3. All right, and then lastly, the limit as x approaches 4 of f of x is 2. So here's 4. The limit as x approaches 4 of f of x is 2. So what does that mean? I must have an open circle here at 2, right? It can't be closed because there's already a closed circle up here. And that means from the right and from the left, I must be approaching that open circle. It has to be from the right and from the left because I was told that this overall limit exists. Now, as far as the rest of the graph goes, well, I could have those two be connected or not. I could go from here down to there. It would have to then approach that open circle. Here, I could have this, and then maybe it connects back up here, and then maybe this goes down here. It doesn't matter some of those other things because it doesn't go against any of those things that I was previously told. All right, and then maybe this side, continues on. We weren't really told the domain, so that's about it.